Hello students, I'm currently on travel, so I'm going to record this, or I have recorded by now and you're hearing this. And so please listen to this lecture, and if you have any questions we can continue discussion when I come back on Monday. We'll have a regular class on Monday. Okay, so it's just for this class we are going to listen to this recorded lecture. So what I'm going to do now first is go over again the number theory concepts that we discussed on in the previous class, and then proceed a little bit further, and then see some other topics. Okay, all right, let's start with this. So we did this last time where I said we work on a class modulo integer, right? So for example, when you work with divisions, mod is actually the remainder, right? So 59 mod 7 means when you divide 59 by 7, what is the remainder? So that is 3. Then we worked with negative numbers too. Negative 59 mod 7 is 4. So how do we do this? 59 mod 7 is repeated subtraction. So we subtract 7 from 59, we get 52, and then again we subtract, we get 45, and so on until we get something between 0 to less than 7, right? So that's what gets us to this 3. Now when you work with negative numbers, say negative 59 mod 7, it means we are doing a repeated addition. Alright, so when the number that you're adding is negative, it's basically like doing something like this. Negative 59 plus a 7, that gets you negative 52. Then negative 52 plus 7, that gets you negative 45. Negative 45 plus 7, that gets you negative 38, and so on. You keep doing that until you come up with something like negative 3, right? If you keep subtracting, you'll get negative. If you keep adding, you'll get to negative 3, and then you'll get that plus 7 is 4. Okay, so again you got something between 0 and 6, right? So then we stop in this case, right? We're working with modulo 7. Right, so that's how we compute the remainder. Now using a calculator, if you want to do that, let me show you how to do that. So when you divide 59, the positive 59 divided by 7, you get something like this. So what you do, you remove that 8, that quotient, and work only with the fractional part, and multiply this by the divisor, which is 7, you get 3. Okay. Similarly, when you work with negative numbers, 59, you divide 59 by 7, you get negative 8.42857. So when you work with negative numbers, you cannot just eliminate this quotient. What you have to do is add the next largest integer, which is 9, right? So add 9, which is next largest integer, to 8, and you get now this fractional part. Now to this fraction part multiply 7, you get 4. Right? So if you want one more example, let's do something like negative, say 78 mod, say 12, not 12, let's do something like 14. Okay, so when you divide 78, negative 78 divided by 14, negative 78 divided by 14, you get negative 5.5714. so what you should do to get the remainder is add 6, because that's the next largest positive integer to this 5. You get 0.42857 something, multiply this by your 14, and you will get 6. So 6 is going to be the remainder, right? Now so we saw all these things last time. Now, as I said, things are equivalent to each other, in the sense that when you do 73 mod 23, you get the remainder to be 4. Similarly, when you do anything else, for example, 96 mod 23, so 73 mod 23 is a 4. Similarly, 96 mod 23 is also a 4. Okay, so what we say is, in the class modulo 23, okay, so in the class modulo 23, 73 and 96 are said to be equivalent to each other. Okay, so we say 73 and 96 are kind of equivalent to each other in the class modulo 23. Alright. Okay, so same thing, another example, class modulo 15, we say what? These value integers, negative 60, negative 45, negative 30, negative 15, all these things are equivalent to each other, because if anything here in this column is divided by 15, we get the remainder to be 0. Similarly, all these integers, negative 58, negative 43, negative 28, negative 13, 2, 17, 32, 47, all these integers, any of them, if you divide by 15, you get the remainder to be 2. So we say all these things are equivalent to each other. Okay, so that's what we mean by class of modulo some integer. Then we can do arithmetic. So 54 plus 49 is mod 15. So what you do is a straightforward way is to add both of them. You get 1 more 3 mod 15, which is 13. But as I said, it may be more efficient if you take this mod operator inside and simplify the numbers such that they always work in, say, for example, if you want to work with mod 15, you always work between with numbers 0 to 14. Okay, so 54 mod 15 is 9, the remainder. Then 49 mod 15 is 4, this is a remainder. So when you want to do this addition, you are working with instead of 54, when you bring this mod 15 inside, it is 54 mod 15 plus a 49 mod 15. That's what you get when you bring that mod operator inside. So you're replacing 54 mod 15 with 9 and 49 mod 15 with a 4. So basically you have 9 plus 4, which is 13. Alright. Now 13 is less than 15, so, or is less than or equal to 14, so you leave it as it is as a reminder. But now let's take this example. When you do 42 plus 52 and you do a mod 15, 42 mod 15 is going to be 12, 52 mod 15 is going to be 7. So when you take this mod operator inside, it is now 42 mod 15 plus 52 mod 15, which is like 12 plus 7. So 12 plus 7 is 19, but 19 is greater than 14. We want everything to be less than or equal to 14 when you work with class modulo 15. So what you do is you again repeatedly apply this mod operator. So you want the result of your arithmetic operation to be less than or equal to 14 or less than 15. When you work with class modulo 15, you want the result of your operation should be less than 15. So 19 mod 15, you get it to be 4. Alright. So similarly, when you do multiplication, 54 times 49 mod 15 is nothing but 54 mod 15 is a 9, 49 mod 15 is a 4. So when you take this mod operator inside, you basically get 9 times 4, which is 36. So 36 is not less than 15. So what you have to do? You have to divide 36 by 15, get the remainder, which is 6. Alright. So when you divide something by 15, in this case, the remainder will be less than 15. That's what division is. You keep subtracting until you get something less than the divisor. Similarly, when you work with negative numbers, you keep adding until you get something less than the something which is positive and less than the divisor. Okay. So Now 42 times 52 mod 15 is, again, you get, say, 42 mod 15 is 12, 52 mod 15 is 7. So when you take this inside, you get 12 times 7, which is 84. And 84 mod 15, because 84 is not less than 15, you have to apply the mod operator again. So 84 mod 15 is going to be 9. Okay. So this is where we stopped last time, and I also went through this, telling that we can kind of do a sequence of multiplications two at a time. For example, when you want to multiply 42 times 56, 98, 108, you don't need to do all these multiplications at a stretch and get this large number. Divide by 15 to get this remainder, which is 3. You know the remainder is always going to be between 0 and 14 if you work with class modulo 15. So why not just do one multiplication at a time, so between these two numbers. So 42 times 56 is what we'll work with first, and we know 42 mod 15 is 12, 56 mod 15 is 11. So what we'll do is 12 times 11, which is 121. No, not 121, it is 132. 132 mod 15 is going to be minus 8, so times 15, so it's going to be 12. Alright, and so now you have 12 replacing 42 times 56. So what you are working now with is 12 times 98, the next integer. And 12 times 98, again, you don't want to work with 98 as it is. You can reduce 98 further, because 98 mod 15 is going to be 8. That's how you get this 8. So it's basically 12 times 8 is 96. 96 mod 15 is going to be 6. So this 6 now really represents these three things together. So it's now you have really 6 times 108. And you don't really need to work with 108 as it is to do the multiplication. To reduce it now, 108 mod 15 is going to be 3, because 15 times 7 is 105. So remainder 108 mod 15, the remainder is 3. So it is now 6 times 3, which is 18. 18 mod 15 is going to be 3. Okay, so the overall value of this expression is going to be 3. Alright. Okay, so let's stop here.